Okay, this one says you're given a function, it's a rational function, but it goes on to say use a computer algebra system. If you want to read the footnote to you, it says you may use any computer algebra system, including your calculator. For example, to take the 10th derivative using Sage, a totally free application that's on the web. You type differentiate, blah, 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 and then that 10 means the 10th derivative. In Mathematica, that's going to cost you money. I want to point out Essex County College used to pay for the license for Mathematica, but they stopped doing it. And the reason for that, it appeared when they looked at the license that they asked who was using it, and I was the only person using it. And although I promoted it to the students to use it and to learn how to use it, the students didn't use it. Right? They weren't using it. I thought this was a great application. It's like having something to use, and I thought people would be using it. Now, granted, there may be lack of interest because there's a lack of interest in what Mathematica can do, but it's a powerful software. But anyway, its command is pretty simple. You do that, you get you use Wolfram Alpha, you get Wolfram Alpha. I will talk about it. And I'll change this over here. I don't have Mathematica anymore, so I'm going to change this. I use Sage, and I'll post a video for that. But the bottom line is, the bottom line, you use your thing and you start to look at the derivatives. And then once you use Sage, you start looking at the derivatives. You do one after another. You really do one after another. And then you wonder, is there a pattern to it? Right? Is there a pattern to it? And that's what I did over here. I looked at these things and I kind of looked at, what the function looked like, what this guy looked like, what the next guy looked like. Let me get my eraser out. I know it's getting pretty busy over here. And then you start to say, I wonder if you can just keep writing this down over and over again. So when you do it, you start, and by the way, you may not see a pattern unless you're carefully looking for it, but I kind of see a pattern over here. And I'll tell you what I'm seeing over here. I'm seeing, this term over here is kind of looking the same each time, right? And the power, like the first derivative, I get a 1, second derivative, I get a 2, third derivative, I get a 3, fourth derivative, 4, so forth and so on. Then someone says, with the fifth derivative, it would look like something. What does it look like? That term at least would look like 1 over the quantity x minus 27 to the fifth power. Let's look at these numbers over here, though. And by the way, I know there's a sign change, but I see 1, 2, I see 6, and I see 24. I'd say they look like factorials to me, all right? With the understanding, it really does look like a factorial, like n factorial. That's all it looks like. First derivative is 1 factorial, second is 2 factorial, third is 3 factorial, fourth is 4 factorial. So I'd expect to see the kth derivative, all right? So let's just talk about that. I see that over there, and I see this pattern over here we just discussed for the kth derivative. By the way, I got to correct my notes. This should be written as f. The k should be in parentheses, and I will correct that, all right? And then I see this alternating sign in the problem, and the first derivative gives me a positive, second is negative. So I'm going to say, gee, that looks like minus 1 raised to some power, and it's either 1 more than the power or 1 less than the power. So it looks pretty good. I got that. And I like to write down minus 1 to the k plus 1. There's other ways to write it down. The other thing I noticed in this thing, I'm looking at this, and I'm always seeing the minus sign. I say minus. And then I see, 4 plus x, always there. I'm always seeing it. I write that down. I'm predicting on it. Then I see x minus 27, always there. What's the power? It's 1 more than the derivative. First derivative is 2, second derivative is 3, third derivative is 4, fourth derivative is 5. I got to correct this one too. And this would be k plus 1. And it's really that simple. What's helping me do that? A machine is helping me do that. Thank you.